The James Webb Space Telescope has discovered impossible galaxies that have baffled many scientists. What is it finding that has astronomers freaking out?
The secular community was very excited for James Webb because the farther out we look, the farther back in time we're supposedly looking, we're approaching the time of the Big Bang itself, if you accept that model. So astronomers expected to see galaxies in the process of forming. That's not what we're seeing, though. We're seeing fully mature galaxies all the way back. So this is consistent with what creationists expected to see. This is not consistent with what secular scientists who believe the Big Bang model expected to see.
The obvious question to ask then is, as creationists, we believe in a young universe, right? But we have these telescopes that are looking, so far back in time according to the secular model. How do we explain that as creationists?
That's a great question.
The James Webb Space Telescope has discovered impossible galaxies that have baffled many scientists. Spike is a former engineer for the U.S. military space program. I'm really looking forward to hearing what you have to say on the subject. NASA spent, I forget how many billions of dollars developing the James Webb Space Telescope just to look deeper into space than had ever been seen before. What is it finding that has astronomers freaking out?
Well, there's actually two categories of discoveries. Re-examining some things that Hubble had previously observed, and now, in addition, looking deeper into space than the Hubble Space Telescope ever could. So we should probably lay a little groundwork first and talk about what the James Webb Space Telescope actually is.
Right.
So launched in December 2021, as you mentioned, very expensive piece of machinery. Actually went a little bit over time in its development cycle, but an amazing piece of technology. I invite anybody to go watch maybe some YouTube videos on that whole process. The deployment process alone is an amazing piece of engineering. It's like a origami in space unfolding. Is really impressive.
I remember watching it, I think it was on Christmas Day in 2021, watching it launch on the Ariane 5 and being like, is it going to make it? Is it going to be in the right orbit? And then just for weeks afterwards watching, okay, there was a live tracker website where you could see what stage it was on, and you're like, okay, the sunshade's unfolding. Oh, is it getting a little bit stuck? Nope. Okay, it's still going. Okay. Oh, it sounds like one of the mirrors is a little bit funky. Oh, I wanted to see what it was going to do. I wanted to see what pictures were coming out of it, and there was just so much complexity and design and engineering that went into the development and the deployment. It was a relief when it finally succeeded.
Sure, because each stage of that process was a nail biter. If something failed, then there's no way to fix it. But everything was successful. We now have this fully functional and operational space telescope, and it's producing some amazing results. It's designed to see deeper into the cosmos, as you mentioned, than any instrument we previously had. It's got a 21-foot gold-plated mirror. It's roughly the size of a tennis court. Roughly 6 times the amount of light gathering power that Hubble had. So as amazing as Hubble was, if you remember when that came out, what a leap forward in capabilities that gave us. James Webb is all that much better. It's similar to like the aperture in a camera. A lot of people are familiar with photography, and the wider your aperture, the more light you can get in, the farther out you can see because you can resolve things better. And so James Webb gives us that ability.
So what is the significance of the James Webb Space Telescope being able to see deeper into space than ever before? What does that mean, and what implications does that have for the scientific community?
Well, from a secular interpretation, the deeper we're looking into space, we're looking farther back into time because the light would have taken much longer to get to us. Therefore, we're seeing the universe as it was previously in history. And so the secular community was very excited for James Webb because the farther out we look, the farther back in time we're supposedly looking, we're approaching the time of the Big Bang itself, if you accept that model. So Hubble had already caused some problems for the secular astronomers in that it was seeing out far enough to where we should have been able to see galaxies in the process of forming.
And according to the Big Bang model, what is the expected time frame for galaxies to form?
Well, before Hubble launched and started giving us all these observations, it was understood that a galaxy would need 4 to 6 billion years to form after the Big Bang. I should say galaxies in general. The process takes some time because if the Big Bang had occurred, it only would have produced energy, which then condensed into matter. The matter gathered itself together into stars. Then several generations of stars would come and go, black holes would form, they would grow over time, and then the black holes would become the nucleus or nuclei of galaxies pulling more material in. Initially, galaxies would be small, irregular clumps of stars that would then merge and form structure, and then you get disks. And at the very end of this process, disks would merge and you get elliptical galaxies. Now that's a lot of detail on that, but the point is this all takes a lot of time, even if it were possible, and there's problems actually with some of these ideas we could talk about. But Hubble was already able to see far enough into space that if the Big Bang were true, we would be seeing the universe as it was less than 1 billion years after the Big Bang had happened. So astronomers expected to see galaxies in the process of forming, if there were any even there at all yet. Hubble found mature galaxies out to the limits of its ability to observe. Now, the one consolation that the secular community had was that it did, at the limits of its observation, there did seem to be a lot of small irregular galaxies also. So they said, okay, there's these mature ones that we don't know how they could have got there, how they could have formed already when this short of a time, less than 1 billion years. But at least we are seeing a lot of small irregulars, so we are, at least seeing the early stages of some of them. Then James Webb came online. And a couple of things happened. First of all, James Webb re-observed a lot of the same regions that Hubble had looked at and took away that consolation that the secular community had relied upon, in that it turns out because Hubble was at the limits of its capabilities, it wasn't able to resolve things, of course, that makes sense. And a lot of the allegedly irregular, immature galaxies that Hubble had seen turned out to be mature disk galaxies once James Webb could see them more clearly.
So when astronomers pointed the James Webb Space Telescope at the same areas of the sky that Hubble had observed, it was like putting on glasses, and it clarified that there were even more mature galaxies than were expected.
Right. Some of the ones that had thought to be irregular and immature, just because Hubble couldn't see them clearly, turned out to be mature. Furthermore, there's a lot more disk galaxies that Hubble couldn't even see that James Webb has found in those same regions. So there's actually roughly 10 times as many disk galaxies in those regions that Hubble had observed compared to what we knew before.
Now, could you clarify for the audience, what is the significance of a disk galaxy being observed as opposed to other types of galaxies?
Well, this goes into that galactic evolution thing we talked about before. You get stars gathered in galaxies, black holes, and then the galaxies are small irregular clumps that then merge and form structure. So the disk galaxy is not the first stage in that process. There's a lot of things that happen before you get to that point.
Gotcha. So it implies that there's a significant history behind the galaxies that are being
Absolutely.
observed.
Multiple generations of star formation and a lot of galactic evolution happening as well. So that's the first category of evidence that James Webb has found that is causing a lot of head scratching in some circles, re-observing what Hubble had already seen and forcing people to reevaluate what is actually there. Now, the second category is leveraging James Webb's capabilities to look deeper into space than we ever had the ability to do before. James Webb is designed to look more into the infrared than Hubble was. And on large enough distance scales, the light from these objects is redshifted. And the farther out we look, the more redshifted these objects are. So the light is shifted into the red end of the spectrum, like our eyes would be incapable of seeing these, for example. So you need a special instrument that is able to even get the light from these things at all. James Webb is designed to do that, which is why it has the range to look more deeply into the cosmos than any instrument we've ever had.
How far back, according to the Big Bang model, can it look?
Right now, the furthest object seen is at 280 million years after the Big Bang. That's a redshift of about 14. Its theoretical capability is redshift of 20. We're not sure if it's actually going to be able to do that or not. That could push it back a bit further, but it's an exponential curve, so it gets more and more difficult to see farther and farther out, if that makes sense.
So the Hubble telescope could look somewhere in the range of less than 1 billion years after the Big Bang, and the James Webb Space Telescope could look somewhere in the 200 million year range after the Big Bang?
Yes, correct. Hubble could go a little bit further than less than 1 billion years after the Big Bang. I should clarify too, we don't accept the Big Bang model. We're talking about these things as the secular community would interpret them. But from their perspective, Hubble could look 300 to 400 million or so years after the Big Bang, whereas James Webb can go deeper. The record right now is a galaxy called MOMZ14, which is 280 or so far away that, according to the Big Bang interpretation, it's 280 million years after the Big Bang.
Something you've mentioned earlier on, you keep talking about mature galaxies. How do we tell if a galaxy is mature, and what is an immature galaxy?
There's several different ways, actually. So we mentioned disk galaxies earlier, and we should probably clarify what that is for people who don't know. So like if you've seen diagrams of our Milky Way galaxy, that's an example of a disk. There's different structures inside some of them, but it's just the disk. It's flat and usually round. But as we mentioned earlier with galactic evolution, that's multiple stages into this overall sequence. So if it's a disk and these ideas of evolution are correct, then that represents a time much further along than the initial stages of this. So the shape and structure of the galaxy is one way. The chemical composition of the stars within it is another way. Had the Big Bang occurred, the only things it could have made are hydrogen, mostly, helium, a little bit of lithium, and maybe a little bit of beryllium, but nothing else. So if stars formed from that, then the early stars were only hydrogen and helium, and again, lithium and beryllium. Well, there's a lot more in the universe today than just those four elements. We're made up of carbon and oxygen and a bunch of other stuff. So where did all those elements come from? Well, according to this worldview, these elements were all manufactured in the middle of stars. So nuclear fusion happened, crunched all the stuff together, made different elements, and then these stars blew up and scattered these elements throughout the cosmos. And then those elements were available to be incorporated into other stars, and eventually planets, and eventually us. So the story goes. Therefore, if you're seeing a galaxy early in time, close to the Big Bang, we wouldn't expect to see a lot of these elements in them yet. But a lot of these galaxies are showing evidence of that anyway. There's a galaxy, JWST Z14-0, which until recently was the record holder for the most distant galaxy ever found. That one has shown evidence of oxygen and dust and some other things that it shouldn't have if it's early in this evolutionary process. So not only are we seeing fully mature galaxies where there shouldn't be any, according to the Big Bang understanding, we're seeing that they would have to be the end product of multiple generations of stars being born and dying even before then. So they're not only mature, but we're not even close to where the beginning is yet, if that makes sense.
So we're looking at these galaxies that are, billions of light years away. How do we tell what they're composed of?
You can take a spectroscopic measurement of the light, and when light passes through a gas, depending on the elements in that gas, certain wavelengths of light are absorbed. You can, if you take a physics class in college, I mean, this is freshman level stuff in the lab. It's fun. So any specific element will absorb specific wavelengths or specific colors of light. So shine white light through a gas and specific colors will be missing on the other side. That tells you what was in the gas. In fact, this is a fun piece of trivia. The element helium was first discovered on the sun, in sunlight specifically, before it was found on Earth. So they named it helium after Helios, the sun god.
Well, that's really neat.
Yeah, so scientists were analyzing sunlight and said, okay, we know what this set of lines is, that's hydrogen, and this set of, but there's this other set of lines or other set of colors missing from sunlight that apparently is an element that we aren't familiar with yet.
So they take a look at the light composition of these galaxies and they can see what they're made of, right?
Right, because you see the wavelengths or the colors of light that are missing, and that tells you the chemical composition of the specifically of the atmosphere of the stars, because the light has to pass through the atmosphere on the way to us.
It's crazy that we can do that at such extensive distances.
Yeah, I mean, astronomy is primarily an observational science. You can't bring a star into the lab and play with it on your bench. But yeah, there's an amazing amount of information we can glean just from examining these signals.
Hope you're enjoying the conversation. We'll get back to it in just a moment. But first, if you're loving the talk show, let me tell you about creation.com. It's our comprehensive website with over 40,000 articles covering everything from the age of the Earth and astronomy to Egyptology and aliens. Whether you're a skeptic with questions, a student doing research, a pastor preparing a sermon, or just someone curious about how science and the Bible fit together, Creation.com has resources for you. You'll find articles by PhD scientists and theologians, information about our events, our online store, streaming documentaries, and so much more. So take advantage of Creation.com. Now back to the show.
Okay, so looking at the chemical composition and the structure and all sorts of different things, we can tell that these galaxies are way more mature than was expected. Why is that such a problem for the Big Bang model, and what were astronomers predicting that they would find?
Well, the Big Bang model doesn't provide time to make these things. I think I mentioned this previously, but before Hubble launched, the expectation was a galaxy would need 4 to 6 billion years to form. Hubble already caused problems in that it was able to look to less than 1 billion years after the Big Bang and found mature galaxies where there shouldn't be any. So everyone was hopeful that James Webb would finally solve this riddle. Surely, if we look farther out yet, we'll finally see the proto-galaxies just beginning to form. Well, that hasn't happened. There's mature galaxies all the way out to the limits of its observation so far. So basically, if you believe in the Big Bang model, you've run out of time to make anything. Because if the Big Bang happened and you needed billions of years, well, Hubble kept looking farther and farther out and reducing that window. The farthest galaxy currently known is only 280 million years after the Big Bang, if you believe that model. There's not enough time to make anything. And not to mention the fact, as we've said, that this represents the end result of multiple generations of things happening before that.
Okay, so how severe is this problem? Like what level of crisis is this for cosmology?
Well, this is interesting to see the reaction of the secular community to this, because a lot of us would expect that maybe you should be questioning your foundational assumptions about the Big Bang in the first place. That hasn't happened, which is interesting. Instead, people are frantically trying to readjust their models of galaxy formation and how quickly stars can form and how efficient that process is and how much mass you need. And they're talking about burstiness star formation and early dark energy and all these other things, which have very little theoretical support, never mind physical support.
But they sound really cool.
But it's interesting that nobody wants to question the overall paradigm of the Big Bang itself. And I think that's actually kind of instructive.
It's funny, when I first heard about this, my first assumption was, oh, okay, so they're just going to say the universe was X many years further, or X many years older, and then they're just going to build a bigger telescope and look further back in time.
I've felt the same way. I've been waiting for someone to say that basically since the Hubble observations first started coming out. There's been a few people who have suggested that. More recently, after the James Webb discoveries, somebody actually suggested adjusting the Big Bang back to 26 billion years ago instead of 13.8, so almost doubling the age of the universe. But those suggestions haven't really caught on. No one seems willing or even able to question the overall framework that they view things through.
Interesting. I wonder why that would be the case.
Well, I think it's illustrative of a larger issue in the whole origins discussion. This isn't, the Big Bang is not really a scientific model anymore. There's been so many changes to it over the years, so many problems that were discovered, but rather than reevaluating the theory, we'll just put another Band-Aid on it. The theory of today is not at all the same as the theory that was first caught on in the mid-60s. Since then, you've had cosmic inflation added, there's dark matter, there's dark energy, there's all this stuff. Maybe there's going to be another change now with the timing of when it all happened as a result of this. We don't know. But rather than reevaluating the theory and coming up with something better, it's not going to be good if it's not based on Genesis, but at least it would be better. No one's doing that, and it illustrates something important in the origins debate. That the worldview you have, the assumptions that you bring to the data, is going to drive where your conclusions can wind up. So we see that happening here. That no one's willing to question the Big Bang, even as their time to make anything is shrinking farther and farther.
Okay, so how do these James Webb Space Telescopes then, you and I believe that there was a creator God who created the universe and created us and everything else. How do these discoveries fit in with what we'd expect if there was a young universe created by an almighty creator God?
Well, these discoveries are perfectly consistent with what we expect. CMI published articles 21 years ago now talking about these sorts of things, saying that because the creation is recent and because the Lord created the universe for specific purposes, one of which is to proclaim his glory and then other reasons, we would expect to see functional, fully mature galaxies to the limits of our ability to observe. And that's what we're seeing.
Okay, so then the obvious question to ask then is, if, as creationists, we believe in a young universe, right? But we have these telescopes that are looking, so far back in time according to the secular model. And the light does take a good amount of time to travel here according to, if we believe that, the speed of light is a constant in a vacuum, all these different things. How do we explain that as creationists?
So that's a fascinating question, and it seems like a simple question, but it's actually not simple. There's a lot of assumptions built into that, some of which are so subtle we don't even necessarily realize that they're there. I actually have a full 1-hour talk just on that subject, exploring 7 different possible solutions to it. I think it's a lot of fun. It's a fun subject. Relativity works in there in a few of them, and there's other ways of looking at things too that, again, aren't necessarily obvious just if you think about that question the way it was posed. So I'd invite viewers, go to creation.com. There's a full 1-hour session available for streaming there where we take a deep dive into that And I think it's a lot of fun.
All right, then we'll make sure to put a link in the description so that viewers can check that out. So with all these issues of mature galaxies at a distance, what would you say to someone who says, well, the scientists will figure it out. They always do. Everything just takes time.
Well, first of all, that's a statement of faith. It's not based on actual fact. It's hoping something will happen in the future that hasn't happened yet. Second of all, science is supposed to follow the evidence where it leads. You're not supposed to assume a conclusion and then try to jury-rig some mechanism to get there. So these observations were not what was expected. There's a lot of frantic readjustment and recalculations and all the rest of it. And eventually somebody will come up with some mechanism that people say, well, it has to be this. We've seen this happen over and over in the origins debate. Generally, that mechanism is not a good mechanism. It's just better than all the other ones that are even worse. So this isn't how science is supposed to work. As I think I mentioned earlier, the Big Bang has already been changed considerably throughout its half a century or so of popularity in the secular community. Probably another bandage will get added just with this one. People seem unwilling to question it, and so why would they start now?
So why does it matter how old these galaxies are anyway?
Well, it ties into the larger issues of who we are and why we're here. And specifically, is the Bible a credible account of history or not? If there is a viable alternative model explaining how we all got here without a creator, well, that calls into question the Bible's account that says a creator was responsible for it. And that has much larger implications, of course. But we are blessed in that the Lord has placed us in a universe that looks created. It operates according to laws of physics that say you can't get something from nothing, nor could there had always been something. That the Lord does not ask us to accept with blind faith that he is the author of all that we see. Instead, he has placed us in a universe that is consistent with our expectations, is consistent with what Scripture says, and we can rest assured in that.
So before we close, what's your big picture takeaway for Christians? Why should we care about these discoveries from the James Webb Space Telescope?
Well, these are consistent with what creationists expected and is inconsistent with what secular models had expected. This is not the first time that's happened, and it won't be the last because we do have the correct viewpoint. So the correct paradigm will produce correct predictions. This is also interesting too because the other side in this debate likes to portray us as just having blind faith in a book and ignoring what science says and ignoring the data and not being able to make good predictions. Well, that's not true. Here's a great example of that. We're seeing what we expected to see. They are not seeing what they expected to see. And a final issue with this is salvation. If there's vast cosmic ages, then you have to reinterpret Genesis in terms of being allegory rather than history, which then calls into question other parts of the Bible where Genesis is spoken of as if it is history. And of course it is. I'm not saying it's not. Paul and Jesus both spoke of Genesis as true literal history. So if it's not actually true literal history, then did they not know what they were talking about? Jesus is the creator. It says that several places in Scripture. Did he not know when he created? Well, you see all the problems that can arise with this.
Thank you very much. It does matter how old the universe is, and it does matter how we were made and how that all fits together, because the Bible tells us how that happened. And if we trust the Bible to be true, and we trust the Lord for our salvation, we have to trust him at his word, even when he tells us what he did.
Right. Ultimately, it's not about whether or not galaxies exist at certain distances. It's about the authority of Scripture.
Yep. Well, thank you so much, Spike. I've really enjoyed this.
Thanks for having me.
I really did enjoy this. This is one of my favorite subjects. For our listeners who are equally interested in this subject and want to learn more about how the heavens declare God's glory and all the interesting scientific discoveries that go along with that, what resource would you point them to?
I'd point them to 3 resources, actually. First is CMI's email newsletter, available on creation.com. I subscribe to it. It's very good. If people are more interested in astronomy specifically, I'd also recommend my email newsletter, which is available at creationastronomy.com. There's a sign-up form at the bottom of every page. And third, I have a 3-video series on astronomy from this perspective. The second volume in that series is specifically on star formation, galaxy formation, talks a lot about what Hubble found, and then at the end talks about why all of this matters. So that's directly related to our conversation here. Doesn't have the James Webb in there yet because some of these discoveries are, just cutting edge stuff. But it does cover the whole history of this and even takes a deep dive into things like star formation and galaxy formation, which we didn't even have time much to talk about today. So that's available on creation.com for streaming, and it is free. So I recommend people go get that.
If you're interested in watching the video that Spike mentioned, we're making it available as a free stream in the link in the description below. thank you so much, Spike, for your time. I've really enjoyed this conversation, and hope we get to have more conversations in the future.
Thanks for having me. It's been great.